Hello, everyone, and welcome to the first episode of Hackers Assemble. Hackers Assemble is a live show sponsored by Igalia. Igalia is an open source consultancy that works from the kernel to the web browser. And I work at Igalia, and here with me is a colleague of mine, Andre Almeida, that is a kernel developer working from Brazil and is here to share with us the work that he has done on supporting case-insensitive file systems on Overlay FS. So welcome, Andre.
Hello, everyone. Thank you very much, Marga. I'm glad to be here.
Thanks, Andre, in particular, for being our very first guest in this episode of Hackers Assemble. We are both very nervous because it's the first one, but we are hoping it will be something nice to share with everybody.
It's very easy to find around the internet people very mad about case insensitive, but it's not so easy to find the full history about why we have this in the Linux kernel. So I think it's fair to share this side of the history, at least on.
Yeah. Let's start with why case insensitive and how we ended up here. Like, what's behind the whole controversy?
Yeah. Okay. So the very very long answer starts centuries of years ago, like in the past we had the Latin alphabet and it was just uppercase letters, and then but in the past people used to write using like a hammer and to carve in the wood and in stone. So that's why when you go to a very ancient place you see everything in all caps, which is kind of rude nowadays. But then when in the Middle Age, when people developed the pen, and the monks, they had this task to copy and copy texts again and again and again. They started to change the letters a little bit to be more fluid to write with the hand and to read, because the Latin alphabet is quite square. It's kind of straight lines. So eventually they developed the lowercase letters, and but this is quite maybe for the Eastern people in the Western world is very natural to have this concept, but this is just for a minority of the languages in the world actually. So if you think about Arabic, of Chinese, Japanese, Korean, they don't even have this concept of file letter cases. So this is something quite particular, and they kind of need to learn like, oh, so you change the shape if it's the beginning of the sentence. Wow, that's strange. So this is how this is why we have different cases. And then after a lot of time, the computers were starting to be developed, particularly in the US, where a lot of things were developed, and the programming languages also were developed there. So you have things like Fortran, Algo, and Basic, and all those languages, they are in the beginning just uppercase language. So we had to write program with all caps all the time. And this came from a limitation of the cards of the, because people were writing code on those tape cards, and you used to have like only 5 holes uh, to have your letter there, and this is not enough resolution to have the entire alphabet twice. And I mean, there already too much going on. I mean, you are putting holes in in a card. You don't want to have different cases, I think, right? So all the programs were just all caps,
Right.
all capital letters in the beginning of the computer science. And because of that, the OS and the files, the first file systems, everything that came along with that, everything was just full
Just uppercuts.
uppercase.
Yeah.
Yes,
I mean,
just
uppercase, lowercase, like there was just one case, right? And as you were
yes.
saying, like it was just Latin letters, just the English letters, not even Latin
Mhm.
letters, just the English one, right?
Yes.
Like the 26 basic ones. They
Mhm.
didn't have like any special letters. Like in Brazilian, there's the I don't know what you call it, the C with the
Yeah,
cedilla or
cedilla. Yes, yes. Or
cedilla.
like the Spanish, the N
The
with the
ñ, yeah.
title.
Yeah.
Exactly.
So in English, there's just these 26 simple letters, and they didn't have this case thing because like it was just uppercase and that's it.
Exactly. And it's funny to think about that when you think about like the ASCII table and all those case things, because maybe if the computer was developed someone else, maybe the ASCII table would be completely different. Uh, so yeah, the English language is very deep in our technology, even how we develop the technology in every aspect. So it's very interesting to see when other cultures start to use the computer and they have other needs. And yeah, we're gonna talk about Unicode later, and Unicode has a lot of fun things to talk about. So
All
yeah,
right.
they have like everything on full caps, and the first DOS file system, that is the FAT file system, it was all uppercase letters,
Mm-hmm.
and then after, so eventually they Windows managed to have different cases for typing and so, but to be able to be backward compatible, FAT needed to be case sensitive. So this is
Right.
like where this everything starts, I think, for the case sensitive file system. So, and FAT was not even uh, case preserving. So that means that even if you could type the file name in a lowercase, but once you created the file, FAT would convert that for only uppercase file system file name. So after that, uh, as Windows were being developed and Windows wanted to be backward compatible with DOS programs in the beginning, it had to be case insensitive. So when NTFS came along, that is like the most popular Windows file system, it had to be case insensitive
Right.
because what came
Backwards
before that,
compatibility. Yeah.
yes,
Yeah.
what came before that was case insensitive. And even if nowadays no one uses DOS anymore, I mean, probably people use, but anyway, even if it's not like a very particular use case, because anything that come after NTFS will be probably we want to be compatible with NTFS, so we need to be case sensitive again. So it's
Mm-hmm.
it's settled like this forever, I believe, in the Windows world.
Yes.
And the same happened with Android. Uh, I mean, Android is Linux, of course, so the internals of Android is not case insensitive, but as it's very common to have SD card that you share between your Android device and your Windows machine, the Android also supports case sensitive, and macOS as well supports case sensitive by default. So, and also there is apart from this backward compatibility thing, uh, it's also of course this is very open to discussion, but some people say that it's more user friendly to have a case insensitive file system, because we yeah, so we are as humans, we live in a case insensitive world. I mean, uh, for the machine, the capital A and the lower A are very distinct thing. You need to teach a machine they are related. But for us, if you go to, I don't know, for the airport, every sign, all the city names, everything is all caps.
Right.
If you get a product in the market, very likely the name of the product will be in all caps. So we perceive the word as all caps. And I don't know, if you say, if you ask someone, oh, please, can you go to my room and get a copy of Harry Potter? The person will go there, and regardless of how Harry Potter is spelled, the person will understand what you mean. The person will be
Yeah.
able to read it. So it would be very confusing. It's kind of confusing for when you were using the files in your computer as well. Like, um, if you, let's say you create a new document and you call like a contract, .pdf with a capital C, and then later you somehow create again, but with a lowercase c. I mean, you really meant the same thing, but the
Right.
computer will, for the computer is different, but it would be very nice if the computer wondered, hey, you already have something with the same meaning here, so you want to overwrite the older file. So yeah, that's why people say it's more user friendly, because
Right.
for,
So
for
that's
us
how it
it's,
is
yeah.
on Windows, right? On Windows,
Mhm.
like if it's contract with capital C or with lowercase c, it's the same file. But then on Linux, they are different files, right? So how
Mhm.
did we get here? Why is it that on Linux they are different files?
Yes, perfect. So for us, the capitals A and lower A are kind of the same information, but for the computer is very very different. And for the computer, it's easier to have case sensitive, because when you're going to compare things, it's very easier to just compare than precisely, like without any kind of casing converting. And when Unix was developed back in the day, it was developed like around the same time the ASCII table was around. So, and they were not so. I don't think that they had this problem with being backward compatible with anything, because they were just creating things from scratch.
Hmm.
And since they were doing that from scratch, it was just easier to be case sensitive. It's so much easier to compare two strings like that. So Unix in the first place, the first file systems were case sensitive, and then Linux, when Linux appeared, it wanted to be kind of not replacing, but it wanted to be to kind of Unix. So then the first file system for Linux was case sensitive, and then after that, everything that came before was needed to be case sensitive to be compatible.
Right. Yeah. Okay. So then we come to the current world where on the Windows side of things, the file system is case insensitive, and then on the Linux side of things, it's case sensitive. And it has been the same like forever. Like
Mhm.
it's like these two words where cases are different. So why does anybody care about having case insensitive file systems on Linux?
Right. So the main use case that we have is to run Windows applications on Linux, particularly Windows games. So nowadays we have like GeoS, that is Linux distribution that we at Igalia help to create it and help to maintain. And we have this all the software stack made to run those Windows games on Linux. And as someone that is writing Windows software, like a game, they have the correct expectation that this game will be run in a case sensitive environment. So they can create like I don't know, a file for the game, for like an asset like music.mp3, and inside the game they can type with whatever case they want to type the file name, and on Windows it works. However, on Linux it does not work. So uh, you need to be you need to have the exact same case on Linux. But I mean, the person that was programming the software was right to expect that. So we have to work around that on Linux. So
Hmm.
you have a workaround on Wine for that. So if Wine does not find the file in the first try, Wine is not sure yet if the file exists or not, because it might be just a different case. So
Different case.
yeah, so what Wine needs to do is to uh, ask for the file system for every single file, and then compare, and then do a case insensitive comparison for every single file. And depending on how long is the path of the file, it could be like a lot of folders, and those folders could be in a very different cases as well. So this is very slow on user space, and also is impossible to be correct because uh, as you know, in Linux we can have two files with the same name but with different cases. And if
Right.
Wine finds that, which file should Wine choose? There's no way of
Right. If
knowing that.
there's a music with capital M and a music with lowercase
Mhm.
m dot mp3, which one does Wine choose?
Exactly. It just grabbed the first one, but we're not sure how if it is the correct one. So if the
Right.
file system in the first place forbid that, so then we are good to go. And this causes some problems with people that want to mod the games, because the mod so the mod will change some files of the game, and on Windows the mod could just type what whatever way they want to change the file to append something in the file. But on Linux, some people discovered that the modifier was, instead of changing the existing file, was just creating a new file with a different case. So uh, that's another problem. So that's why we want to have case insensitive file systems on Linux.
Okay. All right. Yeah. Okay. So it's not just a question of like lowercasing everything and comparing, because it's like very slow, as you were explaining. Like if you do this, like you have to go like file by file. It's very slow. So
Mhm.
what are the alternatives that the Linux ecosystem offers?
So yeah, it's not as I said, it's not that simple. So to be able to have that working correctly from the kernel side, first of all, we don't live in just the ASCII word anymore. People, we have different languages, and aside for English, I actually not if you not consider it like foreign words like resume in English. English is the only language in the planet that fits in the ASCII table. English is the only language that uses just like the plain Latin in some sense. They don't have any accent, but every single other language want to have they have accents, and those letters with accents, people can create files with that, and we need to be able to do case sensitive for those files as well. If it was
Right.
just ask, it was just a matter of flipping one bit, but we need to have a very big table where we can check how to have the case insensitive match for those special letters as well. And this is where Unicode uh, goes in the play. So um, the Unicode tables, they are a replacement or extension for the ask, where you have all the characters for all this language, and Unicode also have the rules for doing the case folding. So uh,
Mm.
when you have two strings and you want to do a case insensitive comparison, you have to have the both strings like in the same level, I would say. So what it does is make the both strings like lowercase, and then you can do a byte by byte comparison. But so you need to have this Unicode table to be able to do this case folding. And so that was Gabriel Krisman, a fellow Brazilian kernel developer, did in 2019. He added the Unicode support for the Linux kernel with thousands and thousands of lines. So if you open the Linux kernel source code, you can find uh, the the UTF-8 table there with a lot of bytes there. And this table is what you use it to properly do this case folding.
Right. So the table is what says like what is the lowercase and the uppercase corresponding letter, like which letter corresponds to which, or what does this table do?
Yes, exactly. So you can use this table to navigate. It's like a mapping. So
Hmm.
you can use this to navigate to know what is the normalized format of this character. And we there are some interesting like corner cases. So for instance, in Greek, you have the sigma letter, and there's one format for the uppercase sigma, but there are two forms for the lowercase sigma.
Right.
So depending if it's in the end of this the
Of the
word,
word.
or the
Right.
middle of the
Yeah.
word, you have different those different things. And in German as well, they have the what's the name, the sharp
The S
s.
set. Yeah.
Yes,
The
the
S
s set.
set. Yeah. Which is written like a beta in Greek letters. It looks kind of like a beta. Yeah.
Yes, it's like a beta. And they this letter usually don't does not appear in the beginning of the sentence, so the
Hmm.
beginning of the word. So for a long time they didn't even had uppercase version for this. So in the past, what they did was to when you want to have a word with that letter in all caps fashion, they would replace this EZ with two S's, and they
Right.
so the Unicode table needs to be aware of that as well. So this is a very interesting case that the length of the original word will change when you normalize that, because now you
Yeah.
have two characters replacing
Instead
just
of one.
one.
Yeah. All
Yeah.
right. So wait, you said that this change was done in 2019, this addition of
Mhm.
the Unicode table to the kernel.
Yes.
2019 seems like awfully late. I mean, Unicode has been around for a lot longer.
Mhm. Yes.
Why was it just done in 2019?
Well, it's because it's very, very controversial, and for the machine, as I said, for the machine is very easier to be case sensitive, because it's very easy for the so it's very easy for the programmer as well to compare things byte by byte. So uh, Unicode also needs to uh, take care not only about this case insensitive thing, but also that is the Unicode decomposed and normalization. So imagine that you are on a web page, and then so those special characters you can like build them. So you have a Unicode character for the N with a title on top that,
Hmm.
and you can compose that. You can have a
Right.
Unicode symbol for just the N and just for the title, and then you combine, and then the web browser will show you the N with a title and not separate things. And but when you are searching the web page, so you type there you want to search for this character, you can type on both ways. So when you are doing this search, the you have the Unicode decompose and normalization that will make both things look the same.
Hmm.
And this is kind of similar to what we're talking about case folded, to have a normal format so things can be compared. And this decomposition is not like 100% accurate. Like you have like 6 ways of decomposing things, uh, and every way has some corner cases. So that's one thing why it's controversial. But
Okay.
one cool thing that you can test in your computer is that if you go to a case sensitive file system and you create a file with like a red heart emoji, and then you create a file with like a black emoji, you can do that in a case sensitive file system, but you cannot do that in a case insensitive file system, because of this decomposition normalization, they will be transformed to the same heart shape, and then there will be a conflict. So this is, I mean, it's not. It might seem like I don't know, a side effect of this case insensitive thing, uh, but yeah, this kind of causes some problems. And I think this year or last year there was a change in the Linux kernel Unicode table to make it to simplify those cases where you were dealing with hearts and another emoji and ignorable code points. And but this change, it kind of broke some file systems because um, it changed how the decomposition works. So it changed the hash of
Right.
those special characters. So when the user update the kernel and uh, try to find a file, the hash was different. So the
Okay.
OS was
Yeah.
like, oh, there's no file like that. The file was there in the disk, but was just not reachable anymore. It was forgotten there. So this is why one another point why is controversial is because it's kind of hard to get it right, and that is impossible to be accurate with this case folding if you don't know the locale that you are working on, like the language that you want to case fold. Because for instance, in Turkish, so in English we have uppercase I and lowercase I. In Turkish, you have four variations of I. So you have the lowercase dotted I, that is what in English we are used to, but you have the uppercase dotted I. So it's a big I with a dot as well. And then you have the same for dotless. So you have a small I without a dot, and you have a big I without a dot. So, and this is how they are mapped. So in English, you map the dotted small I to the big dotless I. But in Turkish, they map the dotless with dotless and dot with dot. So they are mapped in different directions. So
Right.
the Linux kernel right now just compose them as English, but if you are in Turkey, if you and you create those files, it will be wrong for you that speak Turkish. So this is another uh, bad thing about all this Unicode thing, that to be correct, you need to tell the kernel uh, which language you are expecting, and then you have, of course, another big table of languages, and I mean, this would be too much.
All right, all right. But wait, so with the patch in 2019, it was possible to support case folding in the kernel, right? And with that, did we then like move to having like case insensitive file systems, or was there something missing?
So after that, you we have the support for that, but it was not like integrated like in a VFS layer of the Linux kernel. So it was not easy to. It was not like automated support for every file system. So you need to add support for that for every single file system that you want to support. So the first one was X4, that is like the most popular file system for Linux, and then F2FS, that is popular file system for Android, get support for this as well. And then after a while, I appeared in this history with giving support for case sensitive for TempFS and for OverlayFS.
All right. Yeah. And this is the work that you completed recently, the one about OverlayFS. So
Mhm.
let's talk a little bit about OverlayFS. Why do we need OverlayFS? What's it used for? And
So
then afterwards, why you added the case folding
okay.
to it?
So OverlayFS is kind of this meta FS. So it's not like a real file system. It's something that used to compose different file systems together. So you can specify is a file system that works with layers. So you specify an upper layer and a lower layer, and you then specify a third mounting point. So those layers will be combined together in this mounting point. And if there's a file that appears in both upper layer and lower layer, you are only going to be able to see the upper layer file.
Mhm.
So uh, this overlay fast it just like kind of create pointers to, oh, should I look to this file system or this file system. It's just
Okay.
redirects you for different layers depending on how the files of the layers. And this is very useful for containers. So for instance, imagine that you want to install some games, and then this game wants to change some files, wants to change one library or something like that, but you don't want this to impact the base library of your container for gaming. So what SteamOS is working on is to have like the base libraries in the lower layer, and then the game would be mounted as the upper layer. So if the game doesn't have some libraries, it will correctly see the lower part and will be able to use them. But if the game wants to install their own version of something, they will not overwrite the base system. They will write that on the upper part, and then uh, yeah, then the game will be able to use their own file without messing up the base. So this is
Right.
very useful for this container.
Right.
And as explained before, Casefold is very useful for games. So in the past, OverlayFS was didn't like have the support for case folding, because how it works. I can get that on a bit. So uh, we had to add that, so you can use OverlayFS with those casefold file systems. And so the interesting part about this OverlayFS with case insensitive is that every time you want to mount these layers, OverlayFS will need to compare the files that you have in the directory, uh, and then see if you have the same file twice. They will just show you the upper correspondent file. And this comparison of files was being done in a case-sensitive fashion. So one thing that I had to do here, to do for OverlayFS, is to turn this in a case-insensitive um, comparison. If
Mhm.
you if you OverlayFS detects that you are using case-insensitive file systems, it's going to use this case-insensitive comparison. So now you can see, because otherwise you would be able to see both files with different cases, which of course breaks the case-insensitive thing.
Right.
And also we want to be case preserved. So on OverlayFS, you have two strings for every file: the original name and the normalized name. So we want to be sure to show the user the case exactly how it is on the upper layer. So if you have uh, the same file on both layers, but they have different cases, you want to show to the user the case that was chosen for the upper layer.
Yeah. Yeah. Makes sense. All right. And the lower layer, does it have to be inside a case insensitive file system, or can it be in a case sensitive file system and then when you do the overlay FS, you turn it insensitive?
No. They both need to be case sensitive. OverlayFS will refuse to mount, because otherwise you would have a lot of complicated like corner cases. So the way that we did is that they both need to be case sensitive. And in fact, you just to make clear, case sensitive is disabled by default. So even if a lot of people don't like this feature, you can calm down, because it's disabled by default. So you need to enable by, if you want, you need to explicitly ask to ext4 to be case insensitive. And you cannot and then you need also, after that, you need to flip a file attribute for that. So you need to do it at on purpose, and you can do only that for only if the directory is empty. Because if you had something in the directory, and then suddenly the directory turns to be case sensitive, and you have the same file twice, then the file system again would not
Yeah,
know what to do
it
with
wouldn't
two
work.
files. Yes, exactly.
But sorry, I got lost. Which directory are you talking about?
So after you you create like a case insensitive file system,
Mm-hmm.
the directors are not case insensitive by default. So the directors, everything that you create there will be case sensitive, and then you need to flip a flag for the directory and ask the
Uh,
director to be, oh, I want
Directory
this
by
directory.
directory. Each directory
Yes,
needs to be marked
yes,
specifically as insensitive.
yeah, but it's inherent. So if you
Mm.
if you flip for the first directory, everything that is inside the directory, even the other directories, will be case insensitive as well.
All right, I see. So nobody will like suddenly be broken for activating this flag. Like it's very
Yes,
intentional
exactly.
to mark it as
Very,
case
yes, yes,
insensitive.
yes. Hmm.
All right, good, good. We stop the haters. All right.
Yeah.
And regarding the work that you did, is it fully done or is there more work to come?
For overlay FS is fully done. As far as I know, is already being used by humans. But for the case insensitive, there are still things to be solved there. Uh, for instance, on Linux, we have the cache that is kind of a cache for directories for the names, and you have the entries that are the entries of this cache. So this is like very fast. So, and they have negative entries that are for files that the user try to open, but they do not exist. So Linux uh, creates a entry for that, like for a file that does not exist. So if the person creates this file afterwards, after that, um, then the kernel already have like a name for that and already have a entry, so it's faster. But for case sensitive, it's not possible to work with these negative entries because, as I said, we want to be case preserving. So if the user try to create like a file like contract with all lower letters, it will create a negative entry with all lower letters. And then when you create the file, you have the positive entry. But if you create the file like all caps contract, the Linux kernel will use the last name that you choose. So then you're going to be able to create the file with the name that you choose, but it will not be case by case, correct?
Mm.
So this is something that is still needs to be solved for case insensitive for Linux. And yeah, let's see if maybe people want to have these in more file systems. So I don't think it's done. Let's see what else appears.
All right. Yeah. But I still think that it was quite a step forward in the right direction.
Yes, yes. I'm pretty sure that in the comments of this video, you have people saying bad things about case sensitive, but I mean, it's not enabled by default, so you can be in peace. You can relax.
All right. Okay. Well, thank you very much. It's been a great discussion about case insensitive file systems. I really enjoyed it. So thank you for joining the show. The show, and then thank you everybody watching, and stay tuned for our next Hackers Assemble show.
Thank you, everyone.